NASA's South Atlantic Anomaly, a global crisis unfolds. Beneath our feet, a silent upheaval is reshaping the very fabric of Earth's magnetic shield, and the consequences are rippling into space. Imagine a region where the planet's protective magnetic field weakens so drastically that even the most advanced satellites face a heightened risk of failure. This isn't science fiction. It's the reality of the South Atlantic Anomaly, SAA, a growing enigma that has scientists and space agencies scrambling to understand its implications. But here's where it gets controversial. Could this anomaly be a harbinger of a larger, more dramatic shift in Earth's magnetic field? Let's unravel the mystery together. The SAA, a patch of diminished magnetic strength stretching from South America to the South Atlantic Ocean, is no ordinary geological quirk. It's a dynamic, evolving phenomenon that challenges our understanding of Earth's inner workings. Think of it as a dent in the planet's magnetic armor, caused by the chaotic dance of molten iron deep within the core. This geodynamo, the engine behind Earth's magnetic field, is influenced by massive structures like the African Large Low Shear Velocity Province, a dense formation 1,800 miles beneath the surface. These forces create a localized reversal of magnetic polarity, weakening a field in the SAA region. And this is the part most people miss. While the SAA has always existed, its recent acceleration in size and complexity is unprecedented in modern satellite operations. Now, picture a satellite zipping through this weakened zone. Suddenly, it's bombarded by high-energy protons that can trigger data corruption, hardware glitches, or even permanent system failures. The International Space Station, ISS, for instance, orbits through the SAA about 16 times a day, forcing engineers to power down non-essential systems to minimize risks. NASA's ICON mission, designed to study the ionosphere, must constantly adjust its instruments to avoid data loss. But what if the SAA keeps expanding? Could this eventually force a redesign of satellite technology, or even delay critical missions like Mars exploration? The anomaly isn't just a static threat. Data from the European Space Agency's swarm satellites and NASA's SAMPEX mission reveal a disturbing trend. The SAA is splitting into two distinct lobes, each growing larger and moving northwest. This bifurcation complicates orbital planning as spacecraft now face hazards in multiple regions. Scientists are racing to model these changes, using advanced simulations of Earth's core, but predicting the SAA's future remains a puzzle. Could this be a prelude to a magnetic pole reversal? A phenomenon that occurs roughly every 200,000 years? Experts say not yet, but the uncertainty keeps researchers on high alert. NASA and its partners are leading the charge in unraveling this cosmic riddle by combining real-time satellite data with global magnetic models like the International Geomagnetic Reference Field, IGRF. They're refining predictions to safeguard space missions. Yet questions linger. Is SAA a temporary fluctuation, or does it hint at deeper instability in Earth's core? And what happens when the anomaly's reach extends beyond current orbits? As we stand at the intersection of geophysics and space exploration, SAA serves as a humbling reminder of Earth's complexity. It's a call to innovate, to adapt, and to ask bigger questions about our planet's hidden forces. So, what do you think? Should we view the SAA as a warning sign or a fleeting anomaly? Share your thoughts in the comments. Is this a glimpse into Earth's turbulent future, or just a chapter in its long magnetic story? This article is based on verified sources and supported by editorial technologies. Ça vous a plu? 4.3529. Irwin Williams, based in New York with Welsh roots, brings a global perspective to carnarvonherald.co.uk. Covering science, environmental justice, and climate policy, she highlights how local communities respond to global challenges. A graduate of NYU's Journalism Institute, her reporting bridges activism, innovation, and public policy, always with a human lens rooted in place. Contact at your corner to be placed. NASA tracks mysterious splitting anomaly in Earth's magnetic field. NASA is on high alert for a mysterious phenomenon growing in Earth's magnetic field. A massive region of weakened magnetism stretching across the skies between South America and southwestern Africa. This enigmatic area, known as the South Atlantic Anomaly, SAA, has baffled scientists for decades, with researchers at NASA particularly intrigued by its potential risks and mysteries. Imagine a dent in Earth's protective shield or a pothole in space. This is what NASA describes as the SAA, a dynamic zone where the planet's magnetic field is significantly weaker than usual. While this anomaly doesn't directly threaten life on Earth, it poses a serious challenge for satellites and the International Space Station, which routinely pass through it at low Earth orbit altitudes. Here's where things get tricky. The reduced magnetic strength means spacecraft are exposed to high-energy protons from the sun. These particles can interfere with onboard systems, causing malfunctions or even permanent damage to critical components. Satellite operators now have to shut down systems before entering the SAA zone to avoid catastrophic failures. But here's where it gets controversial. Some scientists argue that the SAA might not be a new development. A 2020 study suggested the anomaly has existed for at least 11 million years, hinting that it's not a sudden alarming event but a recurring feature of Earth's magnetic history. However, others worry that the SAA's recent behavior, such as its apparent division into two distinct cells, could signal a shift in the planet's magnetic dynamics. Is this a sign of instability, or is it just part of the natural ebb and flow of Earth's magnetic field? Theories about the SAA's origins are equally complex. One explanation points to the swirling ocean of molten iron in Earth's outer core, which generates the planet's magnetic field. But the field isn't uniform, and factors like the African large, low shear velocity province, a dense rock layer deep beneath the continent, may disrupt its formation. Additionally, the tilt of Earth's magnetic axis plays a role in amplifying the weakening effect. Recent studies have revealed more about the SAA's evolution. In 2016, NASA researcher Ashley Greeley discovered that the anomaly slowly drifts over time, a finding confirmed by CubeSat data in 2021. Even more intriguingly, the SAA seems to be splitting into two separate regions, each with its own center of minimum magnetic intensity. If this trend continues, what does it mean for the future of the anomaly? Will it become more dangerous, or is it simply a natural variation in Earth's magnetic field? Another surprising revelation is that the SAA also influences auroras on Earth. A 2024 study found that the anomaly affects the way charged particles interact with the atmosphere, creating unique patterns in the polar light. While these affairs are still being studied, they underscore the complexity of the SAA and its far-reaching impacts. NASA's ongoing research into the SAA is crucial, not only for protecting satellites, but also for understanding the broader mysteries of Earth's magnetic field. As geophysicist Terry Sabaka explains, the field is a combination of many overlapping forces, and studying the SAA offers a unique window into how these forces interact. Even though the SAA moves slowly, it's changing in ways we need to track, he says. This helps us build models that predict future changes. So what does this all mean for us? While the SAA may seem like a minor oddity, its implications stretch far beyond space. It's a reminder that Earth's magnetic field is far from stable, and that understanding it is key to safeguarding our technological world. What do you think? Is the SAO a warning sign, or is it just another normal part of Earth's magnetic story? Share your thoughts in the comments below. NASA sounds alarm. South Atlantic Anomaly threatens satellites with growing magnetic weakness. Imagine a hidden vulnerability in Earth's magnetic shield that could have profound implications for our technology and understanding of our planet. This is precisely what the South Atlantic Anomaly, SAA, represents. But here's where it gets controversial. Many scientists believe this anomaly isn't just a localized magnetic glitch, but a sign of deeper, possibly unpredictable changes happening beneath our feet. And this is the part most people miss. These shifts could influence everything from satellite operations to our long-term planetary magnetic stability. The South Atlantic Anomaly is a peculiar region over South America and the South Atlantic Ocean, where Earth's magnetic field is significantly weaker than in surrounding areas. This weakness creates a sort of hole in our planet's magnetic defense, allowing high-energy solar particles to come much closer to Earth's surface than usual. For space agencies like NASA, this presents a serious challenge because satellites passing through this zone are exposed to intense radiation, which can cause system malfunctions, data errors, or even permanent damage. Satellites often have to take precautions, shutting down non-essential systems or adjusting their paths to avoid the worst effects of the SAA. Even the International Space Station, ISS, which is well shielded for crew safety, experiences occasional glitches and data losses when passing through this region. For example, NASA's GEDI instrument on the ISS sometimes resets due to radiation spikes, leading to hours of lost data each month. Other missions, like the Ionospheric Connection Explorer, ICON, actively monitor the anomaly and modify their operations accordingly. But the SAA isn't a static feature. Recent data from European Space Agency satellites and NASA's SAMPEX mission reveal that the anomaly is gradually drifting northwest, expanding in size, and, since around 2020, splitting into two separate lobes. This bifurcation complicates predictions and increases the number of hazardous zones for spacecraft, making it more challenging for scientists to develop accurate models of Earth's magnetic behavior. As NASA's experts like Terry Sabaka emphasize, continuous monitoring and adaptive strategies are essential to safeguard current and future space missions. So, what's causing these dramatic changes? NASA links this planetary disturbance to a mysterious energy surge originating deep within Earth's mantle. The core of our planet, driven by complex geodynamic processes, appears to be acting up, possibly influenced by large structures, like the African Large Low Shear Velocity Province, a massive, dense region beneath Africa that disrupts the usual flow of molten iron in Earth's outer core. These internal shifts are believed to weaken and alter the magnetic field, leading to phenomena like the SAA. To better understand these changes, NASA combines satellite observations with sophisticated simulations of Earth's core dynamics. These models, similar to weather forecasts but on a much longer timescale, help scientists track the slow but persistent evolution of Earth's magnetic field, known as secular variation. While the current changes are unprecedented in the space age, geological records suggest that such anomalies have occurred before over millions of years. Importantly, current research indicates that the SAA's evolution does not signal an imminent magnetic pole reversal, a rare event that unfolds over hundreds of thousands of years. Still, studying the SAA is vital, not only for protecting our satellites and space stations, but also for deepening our understanding of the forces shaping our planet's interior. As the anomaly continues to evolve, the scientific community remains on high alert. Its unpredictable behavior raises critical questions. How will these magnetic shifts influence future space exploration? Could they be a sign of larger, more disruptive changes in the Earth's magnetic system? And perhaps most provocatively, are we witnessing the early signs of a planetary magnetic upheaval? Or is this just a natural cycle? The answers could reshape our approach to space safety and planetary science. This discussion is based on verified scientific sources and supported by advanced modeling technologies. But one thing is clear. The South Atlantic Anomaly is more than just a magnetic curiosity. It's a window into the dynamic and sometimes unpredictable heart of our planet. Do you believe these magnetic shifts are part of the natural cycle, or could they be a warning sign of something more profound? Share your thoughts in the comments. This debate is just beginning.